Okay, now let us continue with a 7.2. Okay, refractions at a spherical surface. Now, refractions at a spherical surface, in the previous lessons, we have seen what happened when a light ray travels from a denser to a less dense medium or from a denser to a less dense medium. So today we're going to see what happened if the light ray is traveling from one medium towards another medium at a spherical surface. So if you look at the equations right here, now we have equations n1 over u plus n2 over v equals to n2 minus n1 over r. So how are we going to determine the sign convention for r? That is a crucial thing in this subtopic. Okay, so let's see. Okay, let's assume our light ray is coming from the left-hand side. Okay, if the light ray is coming from the left-hand side and it hits the outer surface of the sphere, for example, like this one. So if it hits the outer surface of the sphere, okay, so this is what we call outer surface. Okay, this side is the outer surface. So if it hits the outer surface of the sphere, then this one we call it convex surface. Okay, convex surface. And therefore, okay, therefore the values for r is a positive value. Okay, r is a positive value. Now let's say if you have a light ray coming from left-hand side again, okay, but what happens right now is that it hits the inner surface of the circle. Okay, so how do I know that it is inner surface? So if you are given a curve and then you try to complete the circle, and you will see that now this light ray is actually hitting the inner surface of the circle, right? So this is a surface right now, and the inner part of the circle is being hit by the light ray. Then this one, we call it concave surface. So when you have a concave surface, when the light ray is hitting on a concave surface, then we have negative r. Okay, your r is a negative value. So that is how we determine whether the radius given is a positive value or a negative value, by looking at the surface. If it is the outer surface, then that we have a positive r. If it is the inner surface, like the one on the right-hand side, the diagram on the right-hand side, then that one is a concave surface. So now let's try example 6. Example 6, you have a cylindrical glass rod in the air, and it has a refractive index of 1.2. So this 1.2 is for the glass. So my n glass is equals to 1.52. One end is ground to a hemispherical surface with a radius. So this end, okay, this is a hemispherical with a radius 3 cm. And then the refractive index given, the refractive index of the air given is Na equals to 1. Now, in this example, it's being very nice to use. They give you the value. In your exam, okay, questions might not give you the refractive index of the air. You yourself have to know the value, which is equals to 1. Okay, so Na is always equals to 1. So calculate the positions of the image for a small object on the axis of the road, which is located 10 cm to the left of the pole as shown in the figure. So this one is our object. It is located 10 cm on the left, okay, to the left of the pole. So this 10 cm is now our object distance. U equals to 10 cm. Okay, U equals to 10 cm right here. So we have object distance U equals to 10 cm. And then we have a hemispherical surface. Now, the things that we have to do right now is to determine whether the R is positive or negative. So let's say now if you complete the circle, you will see that the light ray is actually hitting the outer surface of the circle. So if it is hitting outer surface of the circle, meaning that now this surface is a convex surface. Okay, so this is a convex surface. And therefore, our R is equals to a positive value, positive 3 cm. So that is the values that we have for these questions. And then my next task would be to determine where is N1 and where is N2. Since my object is located on the left-hand side, okay, so the left-hand side of this refracting surface would be my N1 and the right-hand side would be my N2. Okay, the one that is located same side as the object, that one is our N1, and then the other side, the opposite side would be N2. So now let's list down the information that we have right now. So U equals to 10 cm, This is positive 10 cm because my object, is located in front of the refracting surface. And then I have N1 equals to 1.00, N2, which is equals to Ng, which is equals to 1.52, and then I have R, which is a positive value, positive 3 cm. Now, sometimes students will ask me, do I have to change the unit into meter? Okay, not necessary. If you want to use cm, then what you have to do, you just have to make sure your U, okay, U, V, and R, they are all in cm. As long as they have same unit, then you can leave it in cm. If your U and V is in meter, then R must be in meter, okay? So you have to make sure all three of them, they have same unit. That's it. You want to use cm, mm, or meter is totally up to you. So now let us solve these questions. Okay, questions A. So let us apply the equations. N1 over U plus N2 over V equals to N2 minus N1 over R. Substitute the values into the equations. I have 1 over 10 plus 1.52 over V equals to 1.52 minus 1 over positive 3. So V is equal to positive 20.7 cm. Now, since the questions ask you to determine the positions of the image, after you obtain the value, you need to describe where is it. Okay, where is my image? Whether it is in front of the refracting surface or at the back of the refracting surface. So how are we going to tell whether it is in front or at the back? You look at the sign convention. V is a positive value. When it comes to refraction, if you have a positive value, then it means your image is formed behind the refracting surface. Okay, so for refraction, positive value means it is at the back or behind. Okay, at the back of refracting surface. So that is how you determine. You look at the sign. Then if you obtain negative sign, if you got negative sign, then means it is same side as the object, which is in front of the refracting surface. Okay, so you have a refraction. Refraction, this is a transparent material. The glass is transparent. So by right, if your image formed behind the surface, refracting surface, then we have a real image. Okay, so real image gives you positive sign. Therefore, from the value, positive value, I know that it is formed at the back. Oops. Okay, it is formed at the backs of the refracting surface. Okay, so I give you 2 minutes to write it down. Okay, I want you to sketch the diagram on the right-hand side as a short note, as a reminder for yourself. Okay, you sketch this diagram and also this diagram. Just add it in your books. And then complete the questions A. Questions B, just leave it. Okay, questions B is out of syllabus, so I'm not going to discuss it. We will just skip questions B. So 2 minutes for you to write down the answer and also the diagram on the right-hand side. Okay, now let's look at example 7. So example 7, an object O is placed 10 cm inside spherical surface. So now I have spherical surface AB, and now my object is located inside the spherical surface. This is the object. So this spherical surface, it has a radius of curvature 15 cm. All right, and then determine image distance. Now, first of all, you have to know where is your incident incoming light ray. If your object is on the right-hand side, then we are going to assume our incident light ray is coming from the right-hand side. So this is my incident light ray. Okay, incident ray. Okay, so the next step, again, if you want to apply the equations for refractions at a spherical surface, you need to know whether this R is a positive or a negative value. So by looking at the diagram, if I make a complete circle for this AB, okay, and you will see that the incident light ray is actually hitting on the inner surface of the circle, in which it means this R, okay, this surface is a concave surface, okay, and thus the R should be a negative value. All right, so this is a concave surface, so it should be negative R. So R is equals to negative 15 cm. Now, let's look at the diagram. So this diagram, it tells you which one is N1 and which one is N2 already. Okay, N1 is the part that has the same side, located the same side as the object. So N1 is equals to 1.5. N2 is equals to 1. And then my object distance, according to the questions, is placed 10 cm from the AB. So my U is equals to 10 cm. Now again, it is a positive 10 cm because we are going to take here as a front part. Okay, we're going to take the right hand side as a front. So if it is located at the front part of this refracting surface, then your U is a positive value. So now that you have all of the informations, what are we going to do? As usual, we're just going to apply the equations N1 over U plus N2 over V equals to N2 minus N1 over R. N1 is 1.5 right now, and then U is positive 10 plus N2, which is 1, over V is unknown value, equals to 1 minus 1.5. All right, you must follow the subscript. So even though N1 is larger than N2, but if you look at the equation, it asks you to use N2 minus N1. Therefore, it should be 1 minus 1.5, but not 1.5 minus 1. Okay, so over R. So R is in negative value, negative 15. So since my U is in cm, my R is in cm, my V would be in cm as well. So V is equals to negative 8.6 cm. Okay, negative 8.6 cm. So how am I going to describe the positions then? You look at the sign convention. You have a negative sign right here. What does it mean by this negative sign? It means that now you have a virtual image. So if the image is virtual in a refractions, okay, in a refracting surface, then where should it be? In front or behind? Okay, in front of a refracting surface or behind the refracting surface. So since you have a virtual image, the image is located at the same side with the object. Okay, it is located same side with the object, in which it means now it is located in front of the refracting surface. Okay, in front of the refracting surface. So virtual image in front of the refracting surface. Or you can also say it is the same side with the object. So either one, okay? You just choose either one. So how do I know the positions? By looking at the sign convention for image distance. If it is positive, then it represents real image. Real image is located opposite to the object, okay, which is at the back of the refracting surface. If you have a negative sign, then it is a virtual image. Virtual, same side with the object, means that it's located in front of the refracting surface. Okay, so as usual, 2 minutes for you to write it down before we proceed to example 8. Okay, now let's look at example 8. Example 8, now you are given a glass sphere. Okay, so figure shows an object O placed at a distance 20 cm from the surface P. So now you are looking at this surface, surface P, right? Surface P of a glass sphere of radius 5 cm and the refractive index of 1.6. So refractive index of the air is 1. So what am I going to do with this diagram? If you look at this diagram, refractive index of the air is 1. So NA is located at here, which is equals to 1. And this is your NG, which is equals to 1.63. Determine the positions of the image formed by the surface P of the glass sphere. Now, if you have a glass sphere and the question is asking for a final image, then the object, it will undergo the refraction twice. Once by the front refracting surface and another one by the back refracting surface. Right now, the questions A, it asks you to determine the positions of the image formed by the surface P, which is the front surface, the first time refractions, okay, the refractions at the front surface of the glass sphere. So what are we going to do? So when it comes to these questions, you ignore the second surface first. Okay, you ignore the second refractive surface. You're just going to focus on the first refracting surface. So this is your point P, and then object is located 20 cm from P. It means this 20 cm is your U. Okay, so now we have equations N1 over U plus N2 over V equals to N2 minus N1 over R. So what are we going to do right now is we are going to determine the sign conventions again. Okay, we're going to determine the sign convention for this refracting surface. Since your object is located on the right hand side, on the left hand side, sorry, on the left hand side, then we are going to assume the incident light ray is coming from the left hand side. Okay, so this is your incident light ray. So this incident ray, when it hits the glass sphere, okay, as you can see, it's hitting the outer surface of the glass sphere, which means now this first refracting surface is a convex surface. Okay, and for convex surface, we have positive R, so R is equals to positive 5 cm. So N1 is equals to your NA, which is 1.0, N2 is equals to N glass, which is equals to a 1.63. Object distance is positive 20 cm. And then my R is equals to positive 5 cm. So these are the information that I have for the first refracting surface. So let us substitute all of this into our equations. We have 1 over 20 plus 1.63 over V equals to 1.63 minus 1 divided by positive 5. So V is equals to positive 21.5 cm. This 21.5 cm, again, if you look at the sign convention, it shows that this is a real image, and therefore it should be formed behind the first refracting surface. Okay, behind the first refracting surface. So where should I put it? Okay, where should I draw this? Okay, where should I draw the image? Since this green color surface is my first refracting surface, it means that my object, my image is now located somewhere here. Okay, behind the first refracting surface. So this is my image. So from here to here, my V is equals to 21.5 cm. So that is the meanings of the positive sign in your answer. Okay, it is located at a distance 21.5 cm from point B. Now, how am I going to answer questions B then? Now, questions B asks you to find the positions of the final image. Final image means now your object, it undergoes a refraction twice. Once by the front surface and one by the back surface, okay, the second surface. So now let us look at this diagram. after the refractions at the first surface, my image is located at here. Okay, this is my eye. So my eye, this is point P, and then my eye is located at 21.5 cm from point P. That is the information that I obtained based on the answer from questions A. Questions B asks you to find the final image. So we have to repeat the calculations once again, but now it's for this surface. Okay, it's for this second refracting surface. Now, when it comes to second refracting surface, how are we going to determine object distance? Okay, so just now, our object, we take the object on the left-hand side. Right now, we are going to take the image as the second object, the object for the second refracting surface. Okay, the object for second refracting surface. And then this is the refracting surface. So the distance right now is no longer 21.5 cm, it's no longer 20 cm. What we want is this U2. So how to calculate U2? U2 is actually equals to 21.5 cm minus what? Minus the diameter of the glass sphere, which is 10 cm. So U2 is equals to 21.5 cm minus 10 cm. Okay, minus 10 cm, which is then equals to 11.5 cm. Okay, but this one, okay, I'm going to write it. Okay, I'm not going to write it as U2 yet. I'm just going to write it as U. Okay, I'm just going to write it as U. Okay, now if you look at this question, this question is a bit tricky. That is because the image formed by the first refracting surface is located behind my second refracting surface. How are we going to define the front part of the refracting surface and the back of the refracting surface? It all goes back to the original object. O2 is just for us to determine U2, okay, to determine this U. That is the only function, only purpose of O2. But when it comes to determining the front part and the back part of the refracting surface, okay, we have to refer to the original object. So my object, okay, my object is located here. This is the original positions of the object, which means this part is still acting as the front part, and then here is acting as the back of the refracting surface. Okay, so walaupun Anda punya O2 berada di sini sekarang, tetapi apabila kita nak tentukan front part of the refracting surface dan back of the refracting surface, kita kena rujuk kepada positions of the original object. Kamu kena rujuk kepada posisi objek asal. Objek asal saya berada di kiri. So kiri still acting as the front, kanan still acting as the back. Okay, walaupun sekarang saya punya O2 dah berada di kiri. So fungsi O2, it is just for us to determine the magnitude of U2. Okay, to determine the magnitude of U2. So that's it. Other than that, it has no other function. All right, other than that, it has no other function. So since our original object is still located on the left-hand side, we are going to assume our incident light ray is coming from the left-hand side. Okay, kita masih kekalkan kita punya incident light ray punya position because we have to refer to the original object. Okay, kita kena rujuk kepada objek asal. So semua sign convention, okay, all sign convention we determine it based on the original object, not from O2. O2 is just for you to determine the magnitudes of U2. Okay, keep that in your mind. Itu sangat penting. Sebab pelajar sentiasa keliru. Okay, dia keliru. Bila kan nak guna positif, bila nak guna negatif. Kita kena anggap incident ray kita dari kanan ke dari kiri. Wow, it's all based on your original object. Okay, it's all based on your original object. So now let us write down the information. Since I'm assuming my incident light ray is still coming from the left-hand side, it means that this one is my N1, and then here is my N2. So N1 is now equals to N glass, which is equals to 1.63. N2 is not equals to N air, which is equals to 1.0. Then how about R? Okay, so if you look at incident light ray, when incident light ray it hits this refracting surface, it's hitting the inner surface of the circle. Okay, which means now you have a concave surface right here. Okay, concave surface. So your R should be a negative value. So R equals to negative 5 cm. And then how about U2? Now U2, if you look at the diagram, O2 is located behind the refracting surface. Okay, O2 is located behind the refracting surface. So after you obtain the values of U, which is equals to 11.5, then you need to write it as a negative 11.5 cm because it is located at the back of the refracting surface. Alright, so N1, N2 dengan R kita determine based on the original O, okay, original object, and then when it comes to U2, it's based on O2, okay, it's based on O2. So now that you have all of this value, okay, you can then substitute it into the equations again. So N1 over U plus N2 over V equals to N2 minus N1 over R. N1, I have 1.63. U is equal to negative 11.5 plus N2 is 1 over V equals to 1 minus 1.63 over negative 5. Okay, over negative 5. So rearrange the equations, I then obtain my V2 equals to positive 3.74 cm. Okay, positive 3.74 cm. So this is a real image. Okay, this is a real image which should be formed behind refracting surface. Okay, this is real and it is formed at the back of refracting surface. So which means if you want to sketch it in your diagram, then it should be somewhere here. Okay, this is your I2. Okay, this is your I2. All right. So that is how you solve questions 8. When you have an object that is being refracted by the glass sphere twice. Okay, it's being refracted twice. So at the back of second refracting surface, it should be second refracting surface. Okay, so this one I give you some time to write it down. If you have any questions, make sure to ask because this question is a bit complicated, I would say. Okay, so kamu sendiri zoom lah. Saya nak tunjuk kedua-dua diagram pada masa yang sama agak sukar. Okay, so you zoom it. Yeah. Okay, so this is the answer. So kalau ada apa-apa tak faham, pastikan Anda tanya. Okay, sebab example 8 dia complicated sedikit sebab objek kamu dia melalui refractions 2 kali. Sekali oleh permukaan di depan, sekali lagi oleh permukaan di belakang. Okay, it undergoes refraction twice. That's why you have to calculate it twice. Okay, I encourage you to draw a new diagram for questions B, okay, so that you can have a clearer image on what is going on. Kalau kamu semua lukis dalam diagram asal, nanti kamu sendiri yang pening. So you draw two diagrams, one diagram for first refracting surface, second diagram for the second refracting surface, so that you can see clearly what is going on right here. Okay, now let's look at example 9. Example 9. Now you have a small strip of paper is pasted on one side of the glass sphere of radius 5 cm. The paper is then viewed from the opposite side of the sphere. Now, what does that mean? It means now you're viewing it from right here. Okay, you're seeing it here. So this is where you put your screen, okay, where the image is formed. So the positions of the eye, it indicates the positions of the screen, okay, the screen. So the paper is then viewed from the opposite side of the surface of the sphere, determine the positions of the image. So given the refractive index of the glass is 1.52 and the refractive index of the air is 1. So how am I going to answer this question? So when you place a stripe on the right-hand side, but you place it on the surface, then the first medium would be the glass. It won't be refracted by the first refracting surface. Okay, the first refracting surface has no function. Why? Because your light ray isn't traveling from one medium towards another medium. You already place it right here. Straight away, the light is traveling inside the glass. So the refractions only occurs on the second surface. Okay, no refractions on the first surface, but you have it on the second surface. Remember, refractions only occurs if the light ray is traveling from one medium towards another medium. If it is inside the same medium, then nothing happens. So if you place it on the surface, then nothing happened, okay, because it's not traveling between two medium. So what we have right now, okay, we have the glass as the first medium, our N1, and then the air is our N2. Okay, and then since our stripe is on the right hand side, we are going to take incident light ray coming from coming from right hand side, sorry. So this is your incident ray. Okay, your incident ray. So incident ray from right to left, and then N1 is the glass, N2 is the air. The last things that I need to do is to determine whether this surface, the second refracting surface right here, is a convex or a concave surface. If my light ray is coming from the right hand side, then it's going to hit the inner surface of the circle, in which it means this is a concave surface, right? Which tells us that this is a negative R, okay, a negative value. So N1 equals to N glass equals to 1.52. N2 equals to NA equals to 1.00. And then my U, then how about the object distance? Since my object, I place it on the surface, then this diameter is going to be equals to our object distance. Okay, so the questions give you already. So it is the diameter of the circle. So given radius is 5 cm, so diameter, the U is equals to 10 cm. Okay, and then my R is a negative value, negative, okay, negative what? Negative 5 cm. Okay, negative 5 cm. So by combining all this information, okay, I have N1 over U plus N2 over V equals to N2 minus N1 over R as usual. 1.52 over 10 plus plus 1, sorry. 1 over V equals to 1 minus 1.52 over negative 5. So I have V equals to negative 20.83 cm. So once again, you have a negative value. Negative means that this is a virtual image. Okay, virtual image. Virtual image means it is formed in front of the refracting surface, okay, in front of the second refracting surface. Meaning that now your image is somewhere here, okay, somewhere here. This is your eye. So the distance from the surface, from the pole until here, from here until here, is 20.83 cm. Okay, 20.83 cm. So that is the meanings of negative 20.83. All right, so I give you 2 minutes to write it down. And if you are done, then you may try example 10 first. Example 10 is very similar to example 8. The object undergoes refraction twice. Okay, the object undergoes refraction twice, and the question asks you to determine the positions of the final image. So if you are done with questions 9, you may try example 10 first. Okay, now let's look at example 10. So example 10, a point source of light is placed at a distance 25 cm from the center of the glass sphere of radius 10 cm. So now you have radius 10 cm right here. Okay, and then this is your object. Okay, this is your object. So this is your object. Determine the image positions of the source. Okay, now the questions, it doesn't ask you, it doesn't tell you how many times it undergoes a refraction. But since you have a glass sphere, then you yourself should know that you have two refracting surface. One is the front, the first refracting surface right here. Okay, and then the second refracting surface right here. So let us solve it. Okay, let's do the refracting, the calculation for first refracting surface. My object is on the left-hand side, which indicates that my incident light ray is from the left-hand side. Okay, so once again, this is the incident ray. And then when it hits the surface, when it hits this green color surface, it's hitting the outer surface of the sphere, which means this is a convex surface. Okay, a convex surface. Which tells us that my R is now a positive value, which is positive 10 cm. And since my object is located on the left-hand side, so this part would be N1, and here would be N2. So object distance given is 15 cm. So now I have all of the information that I need. So let's solve it for the first refracting surface. So first refracting surface, N1 over U plus N2 over V equals to N2 minus N1 over R. N1, I have the air, which is a 1 over U 15 cm plus N2, which is inside the glass sphere. So I have 1.52 over V, which is then equals to 1.52 minus 1 over positive 10. So if you solve it, you will obtain V equals to negative 103.63 cm. Negative sign. What does it mean by this negative sign? It means you have a virtual image, and the image is located in front of the first refracting surface. That is the information that we obtain based on the values of V. So if you sketch the image, okay, if you sketch it in the diagram, then it actually tells you that your image is somewhere here. Okay, this is the image. Image from first refracting surface. Okay, because I don't have enough space, so I'm just going to assume this is the image. Okay, this is the position. So from, oh, wait, I make a small mistake right here. Oh, yeah, no, it's fine. So this is my I1. So now I'm going to solve it for second refracting surface. So first of all, we have to determine, okay, we have to determine the values for U2. So I1 at the same time, it is acting as O2. Okay, I1 is acting as O2. So my U2 should be determined from here. Okay, should be calculated from here, from the positions of I1. So my U2 is now equals to what? Equals to V, which is okay, from here to here. Yeah. From here to here, it's 103.63 cm. So my U2 is now equals to 103.63 cm plus what? Plus the diameter. Okay, diameter of the glass sphere. So diameter is here to here, which is 20 cm. Because R given 10 cm, so diameter is 20 cm. So plus 20 cm, which means my U2 is now equals to 123.63 cm. So that is the main difference between example 10 and example 8. In example 8, my I1 is behind second refracting surface. In example 10, my I1 is located in front of the second refracting surface. So if it is behind refracting surface, then what should you do? Okay, you calculate U by subtracting the diameter. If it's located in front of the refracting surface, then you calculate U2 by adding the diameter of the glass sphere. Okay, by adding up the diameter of the glass sphere. So my U2 is now equals to 123.63 cm. Then where is my N1 and N2? Now, N1 and N2, when it comes to determining the positions of N1 and N2, you have to look at the original object. Original object is on the left-hand side. So here is N1, here is N2. Okay, here's N1 and here's N2 because of the original object, the positions of original object. So again, my N1 is equals to the glass, which is 1.52, N2 is 1.00, and then for R, okay, now R, if you look at the diagram, my original object is on the left-hand side. So I'm still going to assume the incident light ray is traveling from the left-hand side because of the original object here. Okay, because of this one, not because of O2, because of the original object. So in this case, the incident light ray is hitting the inner surface of the circle. So I have negative R, negative 10 cm right here. And my U2 is now equals to 123.63 cm. Positive, because it is in front of the refracting surface. Okay, because it is in front of the refracting surface. So what am I going to do right now? I'm going to calculate V for second refracting surface. So for second refracting surface, N1 over U2 plus N2 over V2 equals to N2 minus N1 over R. Okay, so you substitute the value into the equations. 1.52 over positive 123.63 plus 1 over V2 equals to 1 minus 1.52 over negative 10. So V2 is now equals to positive 25.2 cm. So this positive sign, it tells you now you have a real image, and that the image is located behind, okay, behind the second refracting surface. So now my image is somewhere here. Okay, this is my I2. So it is 25.2 cm behind this second refracting surface. Okay, so that marks the end of example 10. So I give you 3 minutes to write it down before we proceed to the last subtopic. Okay, to the last subtopic, which is a 7.3, lenses. Okay, so 3 minutes for you to write it down before we proceed to the last subtopic. Okay, we are going to take 5 because of what? Because I just noticed my versions of notes didn't come with example 11, 12, and 13. Okay, so we're going to take 5 while I try to find out where is the example 11 until 13. Okay, kita rehat 5 minit untuk saya cari example 11 sampai 13. Sebab nota saya di sini hilang 3 soalan. Okay, now let us continue. Okay, let us continue with the last subtopic in chapter 7, thin lenses. Okay, so what are we going to do? If you look at the learning outcome, okay, if you look at the learning outcome, in your syllabus, we are going to use thin lenses for a real object only, okay, which means same as a mirror, we are just going to use positive U in this case. It doesn't matter where did you put the object, whether you put it on the right hand side or on the left hand side, we are going to take that one as a real object, okay, as a front part of the refraction of the lens. And then we use lens maker equations. So what is lens maker equations? Let's look at the equations. The lens maker equation is 1 over f equals to, okay, now N2 usually I write it as N material, okay, N material over N medium minus 1, and then 1 over R1 minus 1 over R2. What does it mean by materials and medium? Material is the materials of the lens. Okay, this one is the material of the lens. Then what is N medium? N mediums refers to the mediums at the surrounding. Okay, the surroundings of the lens. Now, usually we conduct the experiments in a room. If it is in a room, then the surroundings of these lenses is the air. Okay, the outer layer, you do the experiment in the air, the vacuum. And then if in some cases, in some of the questions or in one of the passive questions, they actually place this whole lens inside oil. Okay, if you place it in the oil, then what are you going to use as the N medium is the N oil. Okay, if this is the oil, and then now you place the whole lens inside the oil, then in this case, our N medium is N oil. It is no longer N equals to 1. Don't take N medium as 1. Don't always assume it is N1. Okay, you have to look at the medium. Where do you put the lens? Whether you do it in the rooms, okay, in the rooms with air, or you are doing it inside water, you are doing it inside oil, and so on. Okay, so that is the meanings of medium. So we have lens maker equations. Usually we use lens maker equations to determine the focal length of the lens. And then equals to N materials over N medium minus 1, and then 1 over R1 and 1 over minus 1 over R2. What is R1 and what is R2? That is the important thing in this equation. So now let's assume we have the lens again. Okay, we have this lens again. If you're assuming your incident light ray is coming from the left-hand side, then we are going to take the left-hand side as R1 and the right-hand side as R2. And of course, you have to determine the sign convention for R1 and R2. How to determine the sign convention? Same as previous subtopic. You try to identify whether it is a convex or a concave surface. For instance, if you assume the incident light ray is coming from the left-hand side, then R1 would be a convex surface because it's the outer surface of the circle. So it's positive. And for R2, if you draw a circle, then you're going to get a negative value. It is the inner surface of a circle. Okay, so what does it mean by inner surface? If you complete the circle, then the light ray will hit the inner surface of the circle. So positive R1, negative R2, if you assume the light ray is coming from the left-hand side. Now, if you assume the light ray is coming from the right-hand side, then we are going to take right-hand side as positive R1, and the left-hand side would be negative R2, because now it's hitting the inner surface of the circle. So one lens is made up of two circles. So you look at whether you're hitting the inner surface or the outer surface of the circle. Okay, so the positions of object is important right here. It is up to you. Okay, it's up to you whether you want to assume it's coming from the left or coming from the right-hand side. But the positions will change the sign conventions of R1 and R2. Okay, it will change which surface is acting at R1 which surface is acting as R2. It all depends on the positions of the object, as shown in the diagram on the right-hand side here. If it is the left-hand side, then left-hand side of the surface is R1, right-hand side is R2. If you're assuming your object is located on the right-hand side, then the right surface would be acting as a R1 and the left surface will be acting as R2. But does it matter? Okay, does it matter where you put the object? Okay, will it change our final answer? The answer is no. It doesn't matter where did you put it. You're still going to get the same F, the same focal length, the same final answer. Okay, the only thing that it changed is the R1 and R2. So now let's try an example. Okay, let's proceed to example 13. Kita tengok example 13 dulu. Okay, we want to prove that, okay, where you put the object, it doesn't matter. Because it's still going to give you the same F. Okay, the F is the same. So now let's look at example 13. Example 13, the radius of curvature of the faces of a thin concave meniscus. So thin concave meniscus. Now, how am I going to draw the diagram for concave meniscus? So when it comes to concave, it means that both ends of the lenses, okay, is thicker than the center part. So if you're drawing convex, okay, kita tengok convex dulu. If you're going to draw a diagram for convex meniscus, then you have a thicker center part. Okay, the center is thicker than both ends. Oops. Okay, this is the, okay. So the center part here is thicker than both ends. Both ends is just a point, and then the center, it comes with a length. But if you're looking at concave, okay, if you're looking at concave meniscus, then the end, okay, both end is going to be thicker than the center. Okay, so the end. Wait, yeah, let me draw it. So as you can see, here is thicker compared to the center. Okay, the center is thinner when it comes to concave. So that is the main difference between concave and convex. You look at the size. Okay, you look at the length. You compare the length at both edge and the center. So now you have a concave meniscus, length of material of refractive index, 3/2, which is a 1.5. And it has a two surface. One is 20 cm and one is 10 cm. So now let me draw the diagram first. So this is a concave meniscus. Wait here, like this one, and then here. Okay, if you look at this diagram, which surface has a larger radius? Okay, which one has a larger radius? So it's quite obvious that here should have a larger R compared to the inner surface, the inner part. Here come with a smaller R. Okay, because it's more curved. The one that is more curvy come with a small R. Okay, the one that is less curved, it comes with a larger R. So for instance, you know which one is a 20 cm, which one is 10 cm. So this surface is 20 cm, and then here is 10 cm. Okay, here is 10 cm. So what I want you to do in example 13, okay, what I want you to do in example 13, I want you to split into questions A and questions B. Questions A, by assuming now your object is located on the left-hand side. Okay, questions A. And for questions B, what I want you to do, I want you to assume your object is located on the, okay, your object is located on the right-hand side. That is what I want you to do right now. Okay, that is what I want you to do. So I give you 5 minutes to try it. Okay, I'll give you 5 minutes to try it. Draw, okay, solve the questions by assuming your object is located on the left, and also redo it again by assuming your object is located on the right-hand side. Okay, do it for both cases. Buat untuk kedua-dua kemungkinan. Satu, apa yang terjadi kalau kamu biarkan objek kamu berada di kiri. Satu, kalau kamu anggap objek kamu di kanan. Okay, buat untuk kedua-dua. So I have already give you the value, which surface is 20 cm, which one is 10 cm. So now what you want to do, okay, you have to determine where is your R1, where is your R2, and whether they are positive or a negative value. That is your task. Okay, do it now. Okay, now let's go through it together. So first one, if you look at A, by assuming your object is located on the left-hand side, it means that now you're assuming your incident light ray is coming from left-hand side. Okay, so this is your ray. So when it hits the first surface, okay, when it hits the first surface, then this surface would becomes our R1. Okay, this would be our R1. So you are hitting the outer surface of the circle, which means R1 is now acting as a convex surface, and therefore it is equals to positive 20 cm. Okay, it is positive 20 cm. So after it hits the first surface, the light will keep traveling and then hits the second surface. So this one is now acting as our R2, which is also a convex surface. Okay, because if you draw a circle, if you draw a complete circle, it is still the outer surface of the circle. So if you are hitting the outer surface again, then once again, it is a convex surface. and R2 is also a positive value, positive 10 cm here. So if you sub it into the equations, now we have equation, 1 over F equals to, N materials we have a 1.5 over 1 minus 1. Okay, so 1 over R2. Okay, I'm going to write the equations right here. Okay, and material over N medium minus 1, and then 1 over R, R1 minus 1 over R2. So my R1 right here is 1 over 20 minus 1 over 10. So if you got it right, your F should be equals to negative 40 cm. Now let's look at the questions B. Questions B, now I assume my object is on the right-hand side. By assuming my object is on the right-hand side, well, because the questions didn't tell me where is my object, right? So by assuming my object is on the right-hand side, I'm assuming the light ray is coming from the right-hand side. And now it's going to hit the inner surface first. Okay, it's going to hit this surface. So now this surface will become our R1. And if you look at this one, if you make a complete circle right here, you will notice that the ray is now hitting the inner surface of the circle, in which it means now my R1 is actually a concave surface, and therefore it should be a negative value, negative 10 cm, compared to the previous question. Previous question, this surface, okay, in the previous question, this surface is acting as R2, and it gives you a positive value, because the ray is hitting the outer surface. But when it comes to the green color diagram right here, because now your ray is hitting it at the inner part, inner surface, therefore it is now a concave surface. Okay, and now it's acting as R1. Just now it's acting as R2. So after the ray hits the first surface, it's going to keep traveling, and now it comes to the second surface right here. So this surface is now acting as R2, and once again, the ray is hitting the inner part of the circle. Therefore, it is equal to a negative value, so negative 20 cm you have here. So you sub it into the equations, 1 over F equals to 1.5 over 1 minus 1. Now what you have in this part is 1 over negative 10 minus 1 over negative 20. And eventually it will still give you F equals to negative 40 cm. You're still going to get F equals to negative 40. Okay, so as you can see here, here is 1 over 20 minus 1 over 10. Here you have negative 1 over 10 minus negative 1 over 20. If you rearrange this equation, if you rearrange this part, actually you're still going to get 1 over 20 minus 1 over 10. Same as the questions A. Okay, sama seperti soalan A. So that's why I told you just now, it doesn't matter where you put the object. You're still going to get the same F. You're still going to get the same final answer. Okay, that is the reasons why. Sebab walaupun kamu tukar R1 dengan R2, kamu tukar posisi objek, apabila kamu rearrange equation, Anda still akan dapat benda yang sama, 1 over 20 minus 1 over 10. Okay, if you got it right, if you solve it right. Okay, so now I give you 2 minutes to write down the answer before we proceed to example 11, before we go back to example 11. Okay, so harap Anda boleh faham soalan ini. Okay, so tak penting mana kamu letak objek itu. Yang penting cara kamu tentukan R1 dengan R2 serta mereka punya sign convention. Okay, serta mereka punya sign convention. Okay. So now let us go back to questions 11, example 11. So example 11, okay, so how are we going to solve it? A person of height 1.75 meter is standing 2.5 meter in front of a camera. The camera uses a thin biconvex lens. So now you have biconvex lens of radius of curvature 7.69 mm. So you are given just 1R, so it means now both surface, they have same radius. Okay, your R1 is equals to R2, it is equals to 7.69 mm. The only thing right now is that you have to determine whether it is positive or a negative value. So the lens made of a crown glass of a refractive index 1.52. So now this is our biconvex lens. And then according to the questions, now I have a person standing. Okay, so this is the visible line. So my person, person is standing right here. So the height of this person is 1.75 meter. And then it tells me now it is standing 2.5 meter in front of this camera. Okay, so if this is my object, the person is now acting as the object. This is object. So which means now this surface would be act as the first surface. This would be the second surface, R1 and R2. So R1, if you look at this diagram, since my object is on the left-hand side, which means my incident light ray is coming from the left-hand side. So when it hits the first surface, okay, first one is acting as a convex surface. It's hitting the outer surface of the circle. So this would be positive R1. And the second surface is negative R2. It is the inner surface of the circle. Okay, so that is for questions 8. So now let us write down the information that we have first. R1 is equals to positive 7.69. Now, one thing that you have to be careful. This question, it comes with different unit. You have mm, you have meter. So to make it easier, you change all of them into SI unit. So 7.69 times 10 to the power of negative 3 meter. R2 is equal to negative 7.69 times 10 to the power of negative 3 meter. And then object distance U is equal to positive 2.5 meter. Okay, and then what else is missing? Okay, my N glass. N glass is equal to 1.52. So now I have all of them. I can then determine the focal length. Okay, so focal length is 1 over F equals to 1.52 over 1 minus 1. And then 1 over R1 is positive. So positive 7.69 times 10 to the power of negative 3 minus 1 over negative 7.69 times 10 to the power of negative 3. So this is a negative value. Okay, so one positive, one negative. So if you got it right, if you calculate it and rearrange it and got the right answer, your F should be equals to positive 7.39 times 10 to the power of negative 3 meter. So that is the final answer. Okay, that is the final answer. If you got it right, your F should be equals to positive 7.39 times 10 to the power of negative 3 meter. Or you can also write it as 7.39 mm. Okay, it's up to you which one you want to use. Okay, which one you want to write. So questions B, basically you just sketch it. The answer is in your books. Okay, you just sketch it. And then now question C. Determines the positions of the image and also its height. So what is the information that we have right now? Okay, we have F. F equals to positive 7.39 times 10 to the power of negative 3 meter. We also have the positions, the distance of object distance, 2.5 meter. By using these two pieces of information, I can then determine the positions of the image by using 1 over F equals to 1 over U plus 1 over V. Okay? So substitute the equations. The value 7.39 times 10 to the power of negative 3, 1 over 2.5 plus 1 over v. So v is equals to positive 7.41 times 10 to the power of negative 3 meter. Now again, you have a positive value, which means now you have a real image, and therefore the image is located at the back of the lens. Okay, at the back of the lens. Then the second part of the question, it asks you to determine the height. The only equations come with height is m. M equals to hi over ho equals to negative v over u. Okay, so given h object is 1.75 meter, so we have ho equals to 1.75 meter, v from here, and u is 2.5. So now we are going to use this part of the equation. Okay, we want to use this part. So hi is unknown over h object 1.75 equals to negative 7.41 times 10 to the power of negative 3 over 2.5. Rearrange the equations. Hi is then equals to negative 5.19 times 10 to the power of negative 3 meter. Okay, so it comes with a negative sign, which tells you now you have an inverted image. So questions D asks you to state the characteristic of image. So how are you going to state? Remember, use the word loss. L-O-S-T. So L, location, where is my image? Okay, image is at the back of the lens. How do I know it is at the back? By looking at V. V is positive, which tells me that I have a real image, and real image is located at the back of the lens. Okay, look at the back of the lens. O, orientation. Orientation, you look at H. You have a negative sign. Negative sign tells you now you have an inverted object. Inverted image, sorry. Okay, inverted image. And then S stands for size. You just look at the value. HO is 1.75 meter. HI is 5.19 times 10 to the power of negative 3. Obviously, it's smaller. So diminish. Okay, diminish. And then the type of the image. How do you know whether it's real or virtual? By looking at the V again. So V positive, you have real image. So that is how you describe the image, by using the term loss, L-O-S-T. Okay, location, orientation, size, and then the type. So that is the answer for questions, for example, 11. Okay, that is the answer. There's a solution, the full solution. Oops. Okay, so I give you a few minutes to write it down. Then we're going to proceed to example 12, last questions in chapter 7. Okay, now let us proceed to example 12, the last questions. So example 12, now you have a thin plano convex. So what does it mean by plano convex? So this is where the shape of the lens come into play. Okay, you need to know the shape. You need to know what does it mean by plano convex. It's very important. So plano convex, it looks like this. Okay, this is your plano convex. It's made of glass of refractive index 1.66. When an object is set up 10 cm from the lens, a virtual image 10 times its size is formed. So now you have a virtual image 10 times the size is formed. Okay, so let us see. How are we going to solve it? The focal length of the lens. Questions 1 asks you to calculate the focal length. But you are not given the radius, means that you cannot use lens maker equation. So let's see what is the information that we have. So we have n glass, and then we have u. Aha. And then according to the questions, now we have a virtual image that is 10 times of the size form. So m is equals to negative v over u. That is the information that we have right now. Okay. So according to the informations given, what am I going to do? So my image is 10 times. What does it mean by 10 times? 10 times means that the m is equals to 10. So 10 equals to negative v over u. Okay, if I rearrange the equations, v is equals to negative 10 u. Okay, v is equals to negative 10 u. Okay, so next thing. Now that I know v is equals to negative 10 u and I have the values for u, what can I do? Okay, I can calculate the image distance, right? So image distance v is equals to negative 10, which is equals to negative 100 cm. Now I know that it is a negative value. Why? Because the question tells me that it is a virtual image. Virtual image, my v should be a negative value. Okay, my v should be a negative value. So determines the focal length. So now that I have v equals to negative 100 and I have u equals to 10, I can then determine f by using 1 over f equals to 1 over u plus 1 over v. So it is equals to 1 over 10 plus 1 over negative 100. If you got it right, your f should be equals to positive 11.1 cm. Okay, f is equals to positive 11.1 cm. All right, so this question, the crucial part is on whether you know your v is a negative value or not. Okay, how do I know it is a negative value? Because questions tell me now I have a virtual image. Okay, I have a virtual image. If I have a real image, then my v would be a positive value. Then questions B. Questions B asks you to calculate radius of curvature. Radius of curvature, you have only one equation, which is 1 over f equals to n material over n medium minus 1, and then 1 over R1 minus 1 over R2. Now, the question is, it asks us to determine radius, but which one are we going to determine? So let us go back to the diagram. So this is your diagram. Let's assume your object is located on the left-hand side. Okay, then your incident light ray is going to come from left-hand side. So when it hits this surface, this one is acting as R1 and the second one will be acting as R2. By looking at this diagram, the important thing is to know the value for R2. R2 is a flat surface. When you have a flat surface, the radius is equal to infinity. Okay, when you have a flat surface, the radius is equal to infinity. Which means when it comes to questions B, you need to substitute R2 as infinity. So you have 1 over 11.1 equals to material is a 1.66 over 1 minus 1, and then 1 over R1. The values that we want to determine is R1, the convex surface. Okay, the convex surface. So minus 1 over infinity. Okay, so it asks you to determine convex surface. So you have no choice but to place the object on the right-hand side because you want the light ray to hit the convex surface. So 1 over R1 minus 1 over infinity. 1 over infinity, this one, it will give you 0. Okay, it will give you 0. Therefore, these equations can then be written as 1 over 11.1 equals to 1.66 minus 1 times 1 over R1. So 1 over R2 is gone because 1 over R2 is equal to 0. 1 over infinity is equal to 0. So rearrange the equation. R1 is equal to positive 7.33 cm. Okay, positive 7.33 cm. So because convex surface, I put my object on the left-hand side. Okay, so that when the ray hits the first surface, it's convex towards the incident light ray. So that is example 12. Okay, that is the solution for example 12. The crucial part in questions A is to know that your value is equal to negative, your V is equal to a negative value. The crucial part for B is you have to know where to put your object. Your object, okay, you need to place it on the left-hand side because you want your R1 to be a convex surface. You don't want it to be a concave surface. Okay, because question is asking for convex surface.